So this is question 10 from working with polynomials. Again, we're still just kind of working with a monomial, learning some basic rules. So up to this point, we've kind of learned that as far as our rules go, a to the m times a to the n, we keep the same base and we add the exponents. That's kind of called the product rule. Then we have a to the m divided by a to the n, same basis. We can subtract the exponents. That's kind of what's called the quotient rule. We also have a to the m raised to the nth power. If we have a power raised to power, that's called the power rule, which means we multiply the exponents m times n. We've also learned that a to the negative 1 is 1 over a. We also learned that 1 over a to the negative 1 means a. And we also learned that a to the 0 power is 1. Now, another rule is if you have, say, a to the m, b to the n raised to the uh, power of, let's see, m n o q. Let's use a t. I don't know what they actually use here, but so if we have a times a to the m times b to the n raised to the t power, what we can do here is multiply this power through each exponent. We can write this as a to the m t times then b to the n t, if you will. So I don't know exactly what the textbook did there, but we have a special twist on the power rule. So if we look at this problem right here, notice how we have negative 8 times x to the 6, but notice how this negative 8 really is raised to the power of 1. That negative 8 really means a negative 8 to the power of 1. So what I'm allowed to do is I'm allowed to bring this exponent through and multiply this outside exponent to the inside exponent. So that's really going to be a negative 8 raised to the third power times then x, and we bring the power through there. 3 times 6 is 18. So it's going to be negative 8 to the third power times x to the 18th. Now, when you have negatives raised to a negative exponent, well, I'm sorry, when you have a negative raised to an exponent, or it's usually a good idea if you're using a calculator to put the negative number in a parentheses if you're using a calculator. Otherwise, you don't need it. But notice that on a calculator, if I do, say, negative 2 raised to the fourth power, notice how that gives me a negative 16. But we know that if you multiply negative 2 times negative 2 times negative 2 times negative 2, if I do it this way, negative 2 times then negative 2 times negative 2 times negative 2, that would actually be a positive 16. So it's important to, if you have a negative number raised to an exponent, go ahead and put the negative number in parentheses and then raise it to an exponent, and it will do the calculations correctly. So if I have negative 8 to the third power, if you're using a calculator, it's important to go ahead and put the negative 8 in parentheses and then raise that to the third power. That saves you the trouble of doing it by hand. So it's going to be then negative 512. So therefore, this answer is going to be negative 512 x to the 18th power. So notice how this is kind of an extension of the power rule. This outside exponent can multiply to the inside exponents. But remember, the exponent of the 8 is actually a 1. So you don't actually multiply the 3 to the negative 8. You multiply the 3 to the exponent of the negative 8, which is actually a 1. So it's actually negative 8 to the third power. So that's where it gets a little tricky.